Hi guys, let's look at the nomenclature of aldehydes and ketones. Okay, of course the functional groups, the aldehyde, you know the functional group, carbonyl H, 1R group here. It's important to know the sort of the condensed abbreviation for the aldehyde group, the RCHO. We saw that in organic 1, how this is condensed down. Very common, CHO for the aldehyde group. Of course, ketones, two R groups. The R groups can be the same or they can be different. No big thing here. Just we can have symmetrical ketones or non-symmetrical. Some fragments here to make sure we know. Of course, the C double bond O is carbonyl. Many functional groups contain a carbonyl. Aldehydes, ketones, amides, esters, carboxylic acids, etc. We can get a little bit more detailed, specific. If there's an H there, well, this is the aldehyde sort of N group. This is known as a 4-mil group. 4-mil. Now, if we have the carbonyl with a methyl, a single methyl, that's an we've heard that before, but that's an acetyl group, or sometimes said acetyl. I usually say acetyl. Usually. Some example aldehydes or ketones that we've seen before. Benzaldehyde, the 4-mil group, is bonded to the benzene ring. Acetone is a symmetrical ketone we use in lab to wash glassware. Very commonly seen there. The acetyl group bonded to the benzene ring, that's acetophenone. So we should already know these three examples here of aldehydes or ketones. Nomenclature of aldehydes. Pretty consistent with all of our other nomenclature. Longest continuous chain, 1, 2, 3, 4. Carbon chain, that is. It's 4, butane. We're going to replace the E of the alkane with Al whenever it's an aldehyde. Al. You may recall if we did alcohols, we had OL, like butanol or ethanol. The Al is used when we have an aldehyde. Now, the one position is always the carbonyl with aldehydes. An aldehyde is a so-called terminal functional group. The aldehyde carbon is at the end, and it's always labeled as number 1. The 1 carbon, and then we go from there. 1, 2, 3, 4. 4 carbons, butane, butanal. That's the name of that compound there. We could try another one here. We see an aldehyde. Carbonyl's the 1 position. 1, 2, 3, 4. That would be 4. We can get a longer continuous chain by going 1, 2, 3, 4, 5, 6. Not hexane, but hexanal. And then at the 2 position, we have a group coming off of the hexanal, and that's an ethyl group. So the name is 2-ethyl hexanal. Now, by the way, we could have gotten a longer chain here, 1, 2, 3, 4, 5, 6, 7, but that chain does not contain the aldehyde group. The aldehyde group must be within the longest continuous chain. So it's not going to be that 7. Ultimately, because of this and the carbonyl being the 1 position, we might as well start there. 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4. There's really only 2 choices if we start with the carbonyl, and we see it's the 6 hexanal with an ethyl group at the 2 position. Okay, ketones. Longest continuous chain, 1, 2, 3, 4, 5. But instead of pentane, we're going to replace the E with one. And this becomes pentanone. The one indicating we have a ketone here. Now, ketone is actually not a terminal functional group. It cannot be. If the carbonyl was at the last carbon, that would actually be an aldehyde if you think about it or try to draw such a structure. Now with ketones, the one position is not the carbonyl, but as we say here at the bottom, the carbonyl of a ketone is not the one position. The one position is the end of the longest carbon chain nearest the carbonyl. We only have one chain here and it's 5. The end nearest the carbonyl would be this end here. So that's 1. And the carbonyl is at the 2 position. And what we have to do is we denote where the carbonyl is by using that number. And so the name is not pentanone because that's a little bit ambiguous. Instead, it's 2-pentanone, with the 2 indicating where the carbonyl is located. If we look at this compound, which is a constitutional isomer of the one above, this is also a pentanone. Here the one end can be either end, it doesn't matter, it's symmetrical. It would only matter if we put a substituent there. For example, let's put a substituent. Let's put maybe a chlorine here. If there's a chlorine there, still, which end is closest to the carbonyl? Either one. So we're going to look for something else to help us determine which end should be number 1. We're going to make this end number 1. That way, the chlorine can be at the 2 position. Again, either way you go, it's 3-pentanone. But this would be 2-chloro. Pentanone. Here I have 2-pentanone, right? 1, 2, 3, 4, 5. Let's name this compound here. Longest continuous chain that includes the carbonyl. Either way, this is 1. 1, 2, 3, 4, 5, 6, 7. Which end is number 1? Well, it would be this end because this is the end closest to the carbonyl. 3, 7 would be heptane. We change it to heptanone because we have a ketone here. The carbonyl is at the 3 position, so we have 3-heptanone. And then on our 3-heptanone, we have at the 2 position this methyl group, so the compound name becomes 2-methyl-3-heptanone. Pretty straightforward. There should be other naming, discussion, and questions in your textbook. We can add to this cycloalkanones. Cycloalkanes that are ketones. This compound is called cyclohexanone. Basically, if there was no carbonyl, it would just be cyclohexane. All we're doing is replacing the E of cyclohexane with one. Cyclohexane, replace the E with one. And the name of this compound is cyclohexanone. Now the one position is the carbonyl here. There's no end in the ring. And so I said, maybe I said up here the carbonyl will never be the one position. That's actually strictly not correct. If it's a ring, it will be the one position. If it's not a ring, it'll never be the one position, because if you put it at the end of a non-ring, it will be an aldehyde actually. Okay, so I had to adjust that. I see it can be the one position here. This would be cyclopentanone. Cyclopentanone. And then if we put a substituent here, maybe a fluorine here, this would be, what would that be? 1, 2, 3, 4 fluorocyclopentanone. 4 fluorocyclopentanone. Look good? No, no good. That's 3 fluorocyclopentanone, not 4. Because if the fluorine was here, we would number this way. 1, 2, 3. The fluorine would get lowest numbering possible. Either way you go, the carbonyl is 1. I just sort of numbered that way, illustrating the numbering if nothing was there. Right? 3 fluorocyclopentanone. What if we had a bromine here? What would that be? That would be 2 bromo, 4 fluoro cyclopentanone. Because either way you go, carbonyl is 1. This way we get 2 and 4. If we went the other way, we would get 3 and 5. 2, 4 beats a 3, 5. So, the way you go depends on ultimately giving your subs lowest possible numbers for all of them. Okay guys, that's nomenclature of aldehydes and ketones.